हेलो बच्चों, इस एपिसोड विच तुसी इन्हां बारे जानोगे एंगल बिटवीन टू प्लेन्स, जनरल फॉर्म ऑफ अ प्लेन एंड इट्स ट्रांसफॉर्मेशन टू सिमेट्रिकल फॉर्म अते एंगल बिटवीन अ लाइन एंड अ प्लेन। तुसी इन्हां बारे तां जानदे ही होवोगे। प्लेन एंड इट्स इक्वेशन इन स्टैंडर्ड फॉर्म, इक्वेशन ऑफ अ प्लेन इन जनरल फॉर्म, इंटरसेक्शन ऑफ टू प्लेन्स अते प्लेन passing through the intersection of two planes। आओ हुण शुरू करिए। A plane is a surface that joins any 2 points of the surface that lies in the surface. A plane can be specified by some following given things. First one is, a plane can be specified by the normal to the plane and distance of the plane from the origin. Second is, a plane can be specified by a point on the plane and a normal to the plane. Third one is, a plane can be specified by 3 non-collinear points. And the last one is, a plane can be specified by 2 concurrent lines. Equation of plane in normal form. If vector ON is the normal from the origin to the plane and n cap is the unit vector along vector ON, point P whose coordinates are x, y and z be any point on the plane and vector NP is perpendicular to vector ON. Here vector ON is equal to d into unit vector n cap and vector NP is perpendicular to vector ON. Therefore, scalar product of vector NP and vector ON is equal to 0. Now, from the figure, we see that vector NP is equal to vector OP minus vector ON, which is equal to vector R minus D into unit vector n cap. Now, as we have scalar product of vector NP and vector ON is equal to 0, this implies that vector R minus D into unit vector n cap dot D into unit vector n cap is equal to 0, which implies that vector R minus D into unit vector n cap dot unit vector n cap is equal to 0. Because D could not be 0, this further implies that vector R dot unit vector n cap minus D into unit vector n cap dot unit vector n cap is equal to 0, which implies that vector R dot unit vector n cap is equal to D, since scalar product of unit vector n cap to itself is equal to 1. ਹੁਣ ਅਸੀਂ angle between two planes ਬਾਰੇ ਪੜਾਂਗੇ। Angle between two planes. Consider two planes intersecting each other in a straight line. If vector n1 is the normal to one plane and vector n2 is the normal to the other plane, then the planes are described by the equations vector r dot vector n1 is equal to d1 and vector r dot vector n2 is equal to d2. Let us assume that the acute angle formed between the two planes is theta. This further implies that obtuse angle between the two planes is 180 degree minus theta. Since the obtuse angle between the two planes is 180 degrees minus theta, the obtuse angle between the two lines along the planes is also 180 degrees minus theta. Now look at the quadrilateral formed by the normals vector n1, vector n2 and the intersecting lines along the two planes. Applying angle sum property of quadrilateral, we get the angle between the two normals as theta. The acute angle formed between the two normals is same as the acute angle formed between the planes. Similarly, obtuse angle formed between the normals vector n1 and vector n2 is same as the obtuse angle formed between the planes. Thus, we can define the angle between the two planes as the angle between their normals. Let us now calculate the angle between the two normals, which can be calculated by using the fact that dot product of vector n1 and vector n2 is equal to the product of the magnitude of vector n1, magnitude of vector n2 and cosine of angle theta. This further implies that theta is equal to cos inverse of dot product of vector n1 and vector n2 upon magnitude of vector n1 into magnitude of vector n2. The line of intersection of the planes is always perpendicular to both the normals, that is, the vector n1 cross vector n2 is parallel to the line of intersection of two planes. If the normals vector n1 and vector n2 are perpendicular to each other, that means they are at 90 degree angle, then their dot product is equal to 0, as cosine of 90 degrees is equal to 0. This helps us to conclude that if dot product of normals vector n1 and vector n2 is 0, then the planes are perpendicular to each other, as the angle between the two planes is defined as the angle between their normals. On the contrary, if the angle between the normals vector n1 and vector n2 is 0 degree, then the normals are parallel to each other. The fact that the angle between the two planes is same as the angle between their normals helps us to conclude that the two planes are parallel to each other if their normals are parallel. आओ देखिए जनरल फॉर्म ऑफ अ प्लेन तो की भाव है. General form of a plane: let a1 into x plus b1 into y plus c1 into z is equal to d1 and a2 into x plus b2 into y plus c2 into z is equal to d2 be the two non-parallel planes. Their corresponding vector forms are vector r dot vector n1 is equal to d1 and vector r dot vector n2 is equal to d2, where vector n1 is equal to a1 into I cap plus b1 into j cap plus c1 into k cap, and vector n2 is equal to a2 into I cap plus b2 into j cap plus c2 into k cap. The equation of family of planes through the intersection of vector r dot vector n1 is equal to d1 and vector r dot vector n2 is equal to d2 is vector r dot vector n1 minus d1 plus lambda into vector r dot vector n2 minus d2 is equal to 0. The corresponding Cartesian equation is a1 into x plus b1 into y plus c1 into z minus d1 plus lambda into a2 into x plus b2 into y plus c2 into z minus d2 is equal to 0. Thus, the equation of family of planes through the intersection of planes a1 into x plus b1 into y plus c1 into z is equal to d1 and a2 into x plus b2 into y plus c2 into z is equal to d2 is given by a1 into x plus b1 into y plus c1 into z minus d1 plus lambda into a2 into x plus b2 into y plus c2 into z minus d2 is equal to 0. Let us start by imagining a line L where the line L is represented by an equation vector r is equal to vector a plus lambda into vector b, where vector b represents the direction vector of line L. Also, consider a plane intersecting the line L at a point. The plane in such situation is represented by an equation vector r dot vector n is equal to d, where vector n is the normal to the plane. Let us suppose that an angle formed between the normal and the line is theta. As we all know, a normal is always perpendicular to the plane. Therefore, the angle formed between the line and the plane is 90 degree minus theta, which is the complement of angle theta. In other words, we can say that the angle between a line and a plane can be defined as complement of an angle between the line and normal to the plane. Now, as we know an important fact about the angle, let us try to solve the equation further. The angle between the line and the normal can be found by dot product of vector n and the direction vector b of line L, which is equal to magnitude of vector n into magnitude of vector b into cos theta. This further implies that cos theta is equal to modulus of vector b dot vector n upon magnitude of vector n into magnitude of vector b. As we know, cos theta can be represented as sin 90 degree minus theta. It also means that sin 90 degree minus theta is the angle between the line and the normal. Now replace cos theta by sin 90 degree minus theta. In the equation, cos theta is equal to modulus of vector n dot vector b upon magnitude of vector n into magnitude of vector b. We will get sin 90 degree minus theta is equal to modulus of vector n dot vector b upon magnitude of vector n into magnitude of vector b. If we denote 90 degree minus theta by phi, then we obtain sin phi is equal to modulus of vector n dot vector b upon magnitude of vector n into magnitude of vector b. This further implies that phi is equal to sin inverse of modulus of vector n dot vector b upon magnitude of vector n into magnitude of vector b, which gives the angle between the line and the plane.
ਹੁਣ ਤੱਕ ਤੁਸੀਂ angle between two planes, general form of a plane and its transformation to symmetrical form ਅਤੇ angle between a line and a plane ਬਾਰੇ ਪੜ੍ਹਿਆ ਹੈ। ਆਓ ਹੁਣ ਇਹਨਾਂ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਉਦਾਹਰਣਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Let us see another example. Find the angle between the planes 3x minus 2y plus 6z is equal to 8 and 4x minus 8y plus z is equal to 13. पाव ਦਿੱਤੇ ਗਏ ਦੋ planes 3x minus 2y plus 6z is equal to 8 ਅਤੇ 4x minus 8y plus z is equal to 13 ਦੇ ਵਿਚਕਾਰ ਦਾ ਐਂਗਲ ਪਤਾ ਕਰੋ। Now we will see its solution. First of all, let the angle between the two given planes be theta. Now, as the given planes are comparing the first plane with the general form of equation of plane, which is a1 into x plus b1 into y plus c1 into z is equal to d1. Here a1 is equal to 3, b1 is equal to minus 2, c1 is equal to 6. Also, comparing second plane with the general form of equation of a plane, that is a2 into x plus b2 into y plus c2 into z is equal to d2. Here a2 is equal to 4, b2 is equal to minus 8 and c2 is equal to 1. Now, as we know that angle between the two planes is given by cos theta is equal to modulus of a1 into a2 plus b1 into b2 plus c1 into c2 whole divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. Now, on substituting the above values in this formula, we get cos theta is equal to modulus of 3 into 4 plus minus 2 into minus 8 plus 6 into 1 whole divided by square root of 3 square plus minus 2 square plus 6 square into square root of 4 square plus minus 8 square plus 1 square. This further implies cos theta is equal to modulus of 12 plus 16 plus 6 whole divided by square root of 9 plus 4 plus 36 into square root of 16 plus 64 plus 1. This implies cos theta is equal to modulus of 34 whole divided by square root of 49 into square root of 81. This further implies cos theta is equal to modulus of 34 whole divided by 7 into 9, which implies cos theta is equal to 34 upon 63. This implies theta is equal to cos inverse of 34 upon 63. Therefore, angle between the planes is given by theta is equal to cos inverse of 34 upon 63. Which is the required solution.
ਹੁਣ ਤੱਕ ਤੁਸੀਂ angle between two planes, general form of a plane and its transformation to symmetrical form ਅਤੇ angle between a line and a plane ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਉਦਾਹਰਣਾਂ ਨੂੰ ਹੱਲ ਕੀਤਾ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਹੋਰ ਉਦਾਹਰਣਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Let us see another example. Find the angle between the line x plus 1 upon minus 2 equal to y minus 2 upon 3 equal to z plus 5 upon minus 6. And the plane 2x minus y plus 2z plus 7 is equal to 0. ਭਾਵ ਦਿੱਤੀ ਗਈ ਲਾਈਨ x plus 1 upon minus 2 equal to y minus 2 upon 3 equal to z plus 5 upon minus 6 ਅਤੇ plane 2x minus y plus 2z plus 7 equal to 0 ਦੇ ਵਿਚਕਾਰ ਦਾ ਐਂਗਲ ਪਤਾ ਕਰੋ। Now we will see its solution. Let phi be the angle between the given line and the plane. Now, as we know that the general form of vector equation of a line is vector r is equal to vector a plus lambda times vector b. Now here, as the given line is therefore the vector equation of this line is vector r is equal to minus I cap plus 2j cap minus 5k cap plus lambda into minus 2I cap plus 3j cap minus 6k cap Also, we know that the general form of the vector equation of a plane is vector r dot vector n is equal to d. Here, in the above example, the given plane is therefore, the vector equation of this plane is vector r dot 2I cap minus j cap plus 2k cap plus 7 is equal to 0. Now, as we can see here, in case of vector equation of line, b vector is equal to minus 2I cap plus 3j cap minus 6k cap. Also, in the vector equation of the plane, vector n is equal to 2I cap minus j cap plus 2k cap. Here b vector is equal to and vector n is equal to. Now, angle between the line and the plane is given by sin phi is equal to modulus of vector b dot vector n whole divided by magnitude of vector b into magnitude of vector n. Putting the values of vector b and vector n in this formula, we get sin phi is equal to modulus of minus 2I cap plus 3j cap minus 6k cap dot 2I cap minus j cap plus 2k cap whole divided by magnitude of minus 2 I cap plus 3 j cap minus 6 k cap into magnitude of 2 I cap minus j cap plus 2 k cap. Now, as we know that dot product of unit vectors is equal to 1, that is I cap dot I cap is equal to j cap dot j cap, which is equal to k cap dot k cap, which is equal to 1. So here all other dot products will be 0. We know that if vector r is equal to a into I cap plus b into j cap plus c into k cap, then magnitude of vector r is equal to square root of sum of squares of the coefficients of I cap, j cap and k cap, that is magnitude of vector r is equal to square root of a square plus b square plus c square. So now using these two results and then solving, we get sin phi is equal to modulus of minus 2 I cap dot 2 I cap plus 3 j cap dot minus j cap minus 6 k cap dot 2 k cap whole divided by square root of minus 2 square plus 3 square plus minus 6 square into square root of 2 square plus minus 1 square plus 2 square. This further implies sin phi is equal to modulus of minus 4 minus 3 minus 12 whole divided by square root of 4 plus 9 plus 36 into square root of 4 plus 1 plus 4. This implies sin phi is equal to modulus of minus 19 whole divided by square root of 49 into square root of 9, which further implies sin phi is equal to modulus of minus 19 whole divided by 7 into 3, which is equal to 19 upon 21. Now, as sin phi is equal to 19 upon 21, this implies phi is equal to sin inverse of 19 upon 21. Therefore, the angle between the line and the plane is given by phi is equal to sin inverse of 19 upon 21. Which is the required solution. In this episode, you have learned the following: angle between two planes, general form of a plane and its transformation to symmetrical form, and angle between a line and a plane.
ਇਸ ਐਪੀਸੋਡ ਵਿੱਚ ਤੁਸੀਂ ਐਂਗਲ ਬਿਟਵੀਨ ਟੂ ਪਲੇਨਸ, ਜਨਰਲ ਫਾਰਮ ਆਫ ਅ ਪਲੇਨ ਐਂਡ ਇਟਸ ਟਰਾਂਸਫੋਰਮੇਸ਼ਨ ਟੂ ਸਿਮੈਟ੍ਰੀਕਲ ਫਾਰਮ ਅਤੇ ਐਂਗਲ ਬਿਟਵੀਨ ਅ ਲਾਈਨ ਐਂਡ ਅ ਪਲੇਨ ਬਾਰੇ ਪੜ੍ਹਿਆ ਹੈ। ਮੈਂ ਉਮੀਦ ਕਰਦੀ ਹਾਂ ਕਿ ਤੁਹਾਨੂੰ ਐਪੀਸੋਡ ਪੂਰੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆ ਗਿਆ ਹੋਵੇਗਾ। ਧੰਨਵਾਦ।